Welcome to Module 2 of Siemens Online Registered Installer Training. In this module, we're going to go through some of the copper products that are used and how and which one, kind of a product selection guide for how to implement the various topologies that we've showed in Module 1. So let's get started. Before we get into the details of the products, it's good to provide a little bit of background on some of the cabling performance categories that we've been referring to in Module 1. And when we talked about structured cabling standards, we talked about the topologies, but there are also categories which kind of specifies the performance level of the components as well as the permanent link in the channel, so the overall system performance. And when we're talking about these, we're really talking about the bandwidth of the systems, which is really a measure of how much capacity it has for supporting systems. And the bandwidth of a system is measured in hertz, but you'll see it referred to in megahertz, if you will. And in the table below, you can see it starts with category 5E, which has a maximum frequency of 100 megahertz, and it goes all the way up to the latest, which is category 8, which is specified out to 2000 megahertz. And we're not really going to talk about category 8 very much because that's really designed, it's kind of an application-specific media type used for data centers for running higher speeds, kind of shorter distances, but really hasn't been widely deployed in the market as of yet. Our focus for enterprise types of space will pretty much be on categories 5E, 6, or 6A, and we'll talk a little bit about 7A as well. So that's the frequency or the bandwidth and the capability of a cabling plant. But the speed of the cabling plant is really kind of, and it's not really the speed of the cabling plant, but it's the applications that those cabling plants can support. And speed is measured in gigabits per second, and or it's actually measured in bits, but we'll talk about megabits per second and gigabits per second. So again, going back to the channel here, you'll see categories 5E and 6 are capable of supporting 1 gigabit per second, potentially able to support 2.5 and 5, depending on the implementation and deployment. That was a situation where the standards, the IEEE group, wrote some standards for 2.5 and 5 G-base-T to support some wireless applications, and they designed it knowing that really category 6A was the only one that could fully support it, but for legacy customers who wanted to try to support 2.5 and 5 G-base-T, they could try that over various means of 5E and 6, but there are some limitations associated with it, which is why they're in parentheses there. Category 6A supports, in addition to supporting everything behind it, such as 1 gigabits, 2.5 and 5 gigabits, it supports up to 10 gigabits per second, as does category 7A. And category 8, as we mentioned, has the potential to support up to 25 or 40 gigabits per second for shortened distances up to 30 meters. So important to know that these systems are backwards compatible, right? So if you were to install, say you were doing a category 6 installation, but you only had category 6A outlets. If you had a category 6A cable and put in category 6A outlets, you would still end up with a category 6 system. So it doesn't degrade it. You can always use a higher performing component to install a lower performing system. Not necessarily recommended, but it could be done. But the bottom line is it will only operate to the lowest category of performance. So let's take a look at the cable to start with. So the copper horizontal cable types that we're going to be talking about in the next few slides all have 4 pairs of cable, as you can see in the installation: a blue pair, an orange pair, a green pair, and a brown pair, which is fortunately very universal in design. And these will all be comprised of solid conductor cables as opposed to stranded cables, which are typically used in patch cords. The constructions vary depending on the level and the types of shielding or the lack thereof, and we're going to talk about those on the next slide in more detail. So this slide illustrates the 3 most common cable constructions that you will see in the industry. We'll start with the most common one, which is unshielded twisted pair, shown on the top here. We abbreviate it as UTP for unshielded twisted pair. Sometimes you may see it referred to as U/UTP as another way that it's referred to. But that's typically going to be 23 or 24 gauge category 5E, 6, or 6A. Actually going down to category 3, but that's really kind of more of a legacy design. And it's the most prominent construction. So you just effectively have 4 twisted pairs underneath the cable jacket. Very, very simple. The next level up is where you introduce shielding. And so the bottom left shows an illustration of what is referred to as an F/UTP cable, which means it has effectively, the F stands for a foil or shield around an overall UTP cable. So a single foil or shield. So in those cases, you do have the same 4 pairs, but in this case, you have an overall foil around them surrounded by a jacket. And you're typically going to find that on 5-year 6A. There's not a lot of Category 6 level cabling necessarily, but the benefit of the shielding is actually it does have the ability um, to reduce exposure to and radiation of external and internal transmissions, but also has the ability to better dissipate heat for remote powering type of applications, which is why shielded cabling is recommended for support of like power over Ethernet types of applications. The next level is referred to as fully shielded twisted pair, or S/FTP. And as you can see there, in this case, each pair has an overall foil, and then there's an overall shield. In this case, it's actually a braid, which is what the S stands for. There are some constructions out there that are F/FTP, which has individually foiled pairs with an overall foil. The SFTP is what you're going to see for constructions almost exclusively for Category 7A and higher, meaning Category 7A or 8. Also has larger conductors, 22 to 23 gauge, which is what required for some of the performance levels of Category 7A or 8. And of all the cables, it provides the greatest immunity from noise. It has the greatest capability for heat dissipation and overall highest performance for all of the twisted pair cables that we've shown here, UTP or FUTP. Now, when we talk about cables, you do have to be aware of where these cables can kind of be used and the jacket ratings associated with each of them. Shown is an excerpt from the National Electrical Code, which kind of talks about the substitution hierarchy. Typically what you're going to find in a commercial office building is that for riser environments, which are typically going to be found in the backbone or areas below ceilings, you can use a riser cable or a CMR type of cable. For plenum environments, which is usually above ceiling or anywhere there's air handling or air distribution used for the facility, it's required to use a plenum cable. And in returns of substitutions, you can, for example, plenum is the most stringent. It's the most expensive cable, but it's the most stringent. It can be used in a plenum environment, but it also may be used in a riser environment, as well as any general purpose or residential or dwelling in types of environments. So when in doubt, most installers will specify plenum cable just to be safe in case anything got overlooked, but typically a customer will let the installer know what the environment is, or a walkthrough will quickly identify if it's a plenum space or not. The variables that are shown in parentheses there are actually for fiber. Fiber has similar ratings to what you see for the riser, which is CMR, which is communications cable riser, or CMP, which is communications cable plenum. For the riser instances, the OFNR stands for optical fiber non-conductive riser. And OFCR stands for optical fiber conductive riser, which basically means it's an optical fiber with a conductive element in there, typically a shield or an armored for protection. In terms of external cabling options or cabling effectively leaving the building or done outside of the building, there's two types of cables that can be considered. The first is OSP cable, or outside plant cable. And that's cable that usually has it's going to have some type of material inside of it to block water from ingressing into the cable. So kind of a non-conductive water blocking gel. And so those applications are the jacketing is different. These are kind of always, you can have any color you want as long as it's a black jacket. And they can be deployed a number of ways. Sometimes they're buried in the ground. Sometimes they're lashed onto the systems or installed in ducts underground. It's kind of a range. But the problem is that with an OSP rated jacket, it doesn't have the same flame safety ratings for use within a building. So once it enters a building, it either has to be transitioned within 50 feet to another type of cabling, like an inside plant cable, or it has to be installed within conduit, so it doesn't give off any toxicity or spread flame associated with that. For Siemens Solutions, we do have the OSP cable available in Cat 6 UTP, as well as Cat 6A UTP and FUTP constructions. The other option is indoor-outdoor cable, and indoor-outdoor cables are actually cables that are designed to be used kind of in both environments. It's more moisture resistant than water blocking, so think of an area that maybe is a parking garage, so it's outside but not exposed to direct rain, or it's not sitting in underground and buried, anything like that. So kind of a temporary limited moisture inversion has usually a higher temperature range, and it's also ideal that you won't have to transition it to an inside plant cable, when you come into the building, assuming that you can install that into a riser environment. As you can see here, it's only available in CMR, so it's only available to be used in risers, which is not uncommon for where cables come into a building to come into a riser, perhaps a backbone area, and route up to a telecommunications room or to a equipment room of some kind. Those are available in Cat 6A, UTP, and FUTP. So there are some options, but you have to be kind of smart about what you're using when you're leaving the building, because it's going to be a different cable construction than what you use inside the building. So shifting gears away from the cable itself, we're going to talk a little bit about the work area devices, the kind of products that you're going to see used at the end device locations, whether that be a wireless access point, perhaps a security camera, but typically might be a workstation or an office, things of that nature. And in the most common you're going to find here are outlets, faceplates, and surface mount boxes. So you're also going to find some modular furniture adapters and other things like that we have a wide range of. We're just going to cover a few of them here to get you familiar with kind of what they look like in some of the applications. Now, before we get into some of these mounting products, we should touch briefly on the actual connectivity that's going to go at the end of these horizontal cables. The outlet types that Siemens has available are MAX. MAX modules or MAX outlets, our ZMAX outlets, as well as our Terra outlets. Those are the three different platforms we offer for copper connectivity for terminating for outlets, effectively outlets that are having an RJ45 or some type of modular input. As you can see, the Terra is a different type of interface. It doesn't have a standard RJ45 interface. It has a little bit of a unique interface that's designed to accept either a 4-pair Terra plug or can be broken out into individual pairs. For various applications. So when you look at these, which ones you'll be using, it really depends on the categories of cabling systems you're going to be deploying. When you talk about systems that are lower speed type of everyday systems, category 5E and 6 UTP systems, you're talking about using the MAX. Very compact. It's available in a flat, angled, and keystone footprint. So if you want to mount it angled, you order the angled version. If you want it mounted flat, you order the flat version. And the Keystone version that we have is available for use with third-party products. So maybe there's a poke through in the floor, some type of floor box or conference table box. They'll usually have an opening for a quote-unquote Keystone style opening, and that's where you'd use the Keystones for. The termination type for the MAX outlets is either with a punch down, standard single position, 110 style punch down tool, or with the MAX Turbo tool, which we'll talk about in later slides during the installation in Module 3. And these outlets can be passed through. What's nice about them is they can be passed through the faceplate, meaning that you can feed them into the faceplates from the front, or you can feed them into from the back, depending on if you want to terminate your cables, then add the faceplate, or you want to pull your cables through the faceplate and then snap the outlet into location. When you want to talk about shielded systems or higher performing systems, such as Category 6 and 6A, you would refer to our ZMAX outlets. And our ZMAX outlets are available for Cat 6 and 6A in both shielded and UTP. And the termination style for that is with a Z tool, which is included with each box of 50 of those outlets. And that Z tool is a unique tool to Siemens, but it's designed to actually be much simpler to work with than a punch down tool. So it's a non-impact type of tool. It's more of a lacing the conductors in place, trimming them, and then putting into the Z tool and kind of squeezing it with your thumb to terminate. So a little bit different than a regular punch down, but certainly much more installer friendly and much easier on the fingers compared to a punch down style outlet. A little bit different from the MAX outlet. The ZMAX outlet can be mounted in either flat or an angled orientation, so you don't have to specify that when you're ordering that. There is a Keystone variation for that that's a little bit different for those third-party mounting, but the flat and angled are all referred to as a hybrid style outlet for ZMAX, so it can do either or. Then the final outlet, which we referred to before, is the Terra outlet. It's designed for work with Category 7A or actually 8 terminations. It's designed to terminate fully shielded cables, which are those SFTP cables we talked about. Very similar in terms of a toolless design. It's kind of identify your conductors and insert them through the lacing module and then kind of crimping it closed to do the termination. It could be done with parallel pliers. And these outlets can only be mounted flat unless they're mounted in a specific faceplate to position them in kind of an angle style orientation. So something to keep in mind when you're doing that. Now, When we talk about, terminating on SFTP cable, there are instances where customers may choose to use a Category 7A cable, like an SFTP cable, in their horizontal. They don't always have to be terminated on Terra. If the customer is looking for a Category 7A system, then they would have to be terminated onto Terra. However, some customers may opt to use Category 7A cable for its lower delay skew, for example, for video applications, or for its better remote powering performance for support of PoE. In those cases, you can terminate a Category 7A cable on a Category 6A, for example, shielded ZMAX outlet. We have that identified in the instructions for doing that. Just a point of reference that if you do that, the whole system will be rated for the lowest performing component, which would be the ZMAX 6A. So by doing that, you will get a Category 6A performing system, but it will give you that RJ45 interface for customers that are looking for some of those benefits of the Category 7A cable. Now, when you're terminating these outlets, there's typically going to find on nearly every manufacturer's outlets two different wiring schemes, shown here, either T568A or T568B. These were kind of more decision point for customers. It was more important to them when they were using applications that didn't use all four pairs. Most modern day communications infrastructures are using all four pairs for gigabit Ethernet or higher. Perhaps if you're using 10/100 base T, it might be a little bit different if you're terminating onto connecting blocks, but customers will typically have a wiring scheme that they prefer, and that's usually specified in their documentation. If there's nothing there, TIA recommends the T568A wiring scheme. And in the illustration on the far left, you can see that's the back of a MAX outlet, and you can see there's a color code scheme provided for both T568A and T568B on the outlet itself. You'll notice that the blue and brown pairs don't change. It's really just the orange and greens that change, that breaks those pairs and changes and introduces two different wiring schemes. Now we talk about what the outlets kind of go into, what you'll see in the work area. You're going to see faceplates can come in a variety of shapes and sizes. The standard faceplates that we show in the kind of the middle in white there are available in single and double gang, in both side stacked or 10G versions. Now the 10G version is what's shown there, where the outlets are not side stacked right next to each other in a longer opening, and that's really designed to optimize alien crosstalk performance or crosstalk between adjacent cables or outlets, and it's required for Category 6A UTP systems. But some customers just prefer the look of having distinct outlets with a little bit of space between them, so they can certainly be used for anything that's not necessarily a 10G application. You can fit up to 6 ports in a single gang faceplate if they're all stacked side by side, or up to 4 if they're stacked discretely, and that goes up to 12 ports when you're talking about a double gang type of version. We also have a stainless steel option, which is shown on the right. Some customers just have that preference, so they like the extra durability for doing that, available in single and double gang. We do not have 10G options for those, so if a customer is looking to install a Category 6A UTP system, they would either have to use the plastic faceplates, or they could use a blank between the modules. So for example, if you use a 3-port faceplate which has an opening 3 ports wide, you can put an outlet in the first and third port and put a blank in the middle. That would also be determined to be compliant. So for those, it's important to reference that we do have the stainless steel faceplates with and without the labeling options. Some customers would prefer not to see that, or they might be in an area where they think those will get torn or damaged. Other customers, that's a kind of a nice differentiator because they're used to getting stainless steel faceplates without any area for administration or designation, so they prefer that. And then we also offer a 1-port wall phone for customers that do have those applications where they still might want a wall phone that has the mounting posts on there, and those faceplates actually come with the outlet included, because it is one of the Keystone outlets. It's one of the only mounting solutions that uses the Keystone outlets, but it comes with it, so it kind of takes that out of the equation. In the bottom left, we show mounting frames, which are referred to in our duplex, which are kind of like Decora style frame. Duplex, which are more of an electrical style frame, and our designer faceplates, which are more of a Decora style frame. As customers who prefer to have their connectivity look at and share a similar appearance to their electrical systems. So for side stacked outlets, you can put up to 4 ports. For 10G, you're really just talking 2 ports here. So something to keep in mind, there is some density limitations with those, and those are also specified on the duplex or electrical style versions of that. They're specified for whether they're for use with angled or flat modules. And finally, we'll talk a little bit about modular furniture. modular furniture systems are designed to be somewhat universal, but their openings may vary. So we do have some dedicated, all the furniture faceplates are 4-port. We do have some dedicated plates depending on the opening, or we also have a universal modular furniture adapter, which is shown on the bottom there, which is really designed to fit a range of openings and is kind of ideal if you don't know what that opening is or can't get specification on that. When it comes to wanting a little bit of an outlet box to offer a little bit of physical protection where a faceplate just doesn't make sense, there's no mounting area for a faceplate, we do offer service mount boxes in 1, 2, 4, and 6 ports. And fortunately, these do have 10G compliant spacing, so if you're using them with the Category 6A UTP system, you don't have to worry about any additional spacing for those. The nice part about that is they're also UL 2043 compliant, which means they can actually be used in plenum spaces. So again, really intended for some of these difficult mounting locations and above the ceiling applications where a plenum is a requirement for both the cable and the products that are used up in those places. So there are two families of service mount boxes. There's the ZMAX version, which can be used with kind of the product shown here, which can be used with the hybrid ZMAX, which is flat or angled, although you use the flat mounting here. Also supports some of our multimedia stuff, our AV type of stuff, and our fiber stuff that's designed to fit that flat footprint, as well as our Terra outlets. When you get into the MX XM product series, that's really designed for flat max modules only, and it's designed to be used so that you actually snap the flat max modules into the area where typically the color-coded icons will go, and in this case the color-coded icon can just go on the top of the outlet box. So there are a couple different platforms you can use. The ZMAX outlets, if you choose to just kind of want to standardize on them, you certainly can. You can use the flat max modules in there as well, but you would need the icon to kind of hold it in place within that opening. So it might just be more of a point of preference or commonality of inventory. Now for the 3 and 4 connector channel models that we showed in Module 1, when deploying using a consolidation point, you would need to implement what's referred to as a zone enclosure for the zone cabling. And in that consolidation point, we do have a few different flavors depending on kind of more the density that you're planning on deploying them. So when you're doing these types of solutions, you're either going to be doing fewer larger zone enclosures, or you're going to be doing more smaller zone enclosures, if you will. So we have products that address both of those that we're going to talk about on the next slide. So the zone enclosure on top is the 24-port zone enclosure, which accepts our Max, our ZMAX, and our Terra outlets. So very basic. It's got that UL listing. Actually, both of these have the UL listings for use in plenum types of spaces. But the 24-port zone enclosure is actually a very cost-effective, nice, economical, not a lot of bells and whistles. Just bring your cables into that center panel there where the outlets are snapped in, and then the cords go out the other side. So really designed for having more smaller zone cabling deployments, but something that can be very cost effective, and it's very easy to mount above ceiling application or perhaps on a wall, something along those lines. If you want to put the cabling directly in a 2x2 ceiling tile in a drop ceiling, then an option could be the zone ceiling enclosure, which we've shown on the bottom here, which is a much kind of higher density type of application, as you can support up to 4 U's or 4 rack mount spaces of connectivity into these locations. So if you consider having a 48-port, 1-port patch panel, you can get up to 96 ports in that footprint. But it's a little bit more of a complex design. It has to be attached and suspended from the ceiling above, so it's a little bit more complex to install. And also the connections are all they are all accessible from that below the ceiling, which are kind of nice. So you can drop that ceiling panel door open and get to any of the connections, visibly to be able to see what you're doing there. So it really, again, boils down to, do I want more smaller zone enclosures, or do I want fewer larger zone enclosures, and how is those going to be mounted? Those two considerations right there will help you decide which one would be best for your application. So now that we've covered horizontal cable and the connectivity at the work area, let's go into the telecommunications room and take a look at what that horizontal cable is going to terminate onto. It's going to terminate onto one of two kind of platforms, if you will. The first is going to be patch panels, which are really designed, typically like an RJ45 type of design, where you're terminating on the back and then coming out with a standard patch cord on the front. or the cabling is going to terminate onto connecting blocks. And we'll talk about those if you're familiar with the language on that. That would be a 66 block or a 110 block or a 210 block, depending on the category and the application. But those are really intended more for low speed, kind of cost effective terminations when you consider it. It's not really designed for anything above category 5E or 6, and we'll highlight those in the future slides. So if we talk about patch panels, we have a few different flavors to choose from depending on, again, very similar to the outlets, depending on the connectivity you want and the construction of the cable, whether it be shielded or UTP. So starting off, kind of basic working away from left to right, we start off with our max patch panels, which are patch panels that you would effectively install the same max outlets that you would at the work area into a patch panel. So it's discrete ports. They're open panels. So if it's a wide open solution, there could be 6 ports across and banked in. So you install typically a flat black max module in there with an icon to kind of hold it in place. So the max modules are designed for categories 5E and 6 UTP solutions. They're not available in shielded. Use the max outlet to terminate them. The panels are available in both flat and angled constructions, as are all the rest of them. Flat and angled, meaning a flat panel is exactly that. It's a flat patch panel going across. Typically has a horizontal cable manager above and below that the cables route into. An angled patch panel is actually, it's kind of shaped like a V. It's kind of coming toward you so that the patch cords are really can theoretically really exit out at an angle and go right into the vertical managers that are installed on either side of the rack, eliminating the need for horizontal managers. It's kind of a customer preference if customers prefer that type of design. Also, you have to be careful that you don't design too many angle panels in the rack that you can overwhelm any of the cable management as well. So it is a little bit of a customer preference. And when you talk about the density of a max panel, you're getting 24 ports typically in a one rack mount space or one U patch panel. So if you have 45U in a rack, 45U spaces of mountable equipment, you could, you could do the math on that one. But each 7-foot rack typically has 45U rack mount spaces, and in each U you would get 24 ports of density on a max outlet. For the HD, same categories of cable. It's applicable to categories 5E and 6, UTP and shielded. The only difference is instead of terminating it onto a max outlet and then snapping the max outlet in place, you're terminating directly onto a panel that has all the outlets pre-installed. They're not actually max outlets. They're just actually integrated outlets onto the patch panel. So for the sake of cost, it's a little bit more cost effective and it's a little bit easier to terminate because you don't have to worry about bringing cables into place. So it's kind of a fully integrated style patch panel design. It has the same flat and angled design, same density in there, so it really just kind of a customer preference in terms of if you want to terminate individual outlets and snap them in, or just do kind of mass termination onto patch panels. Generally, the HD panels are the types of patch panels most people will use for a 5E or 6 type of installation. Whereas the max patch panels are used typically if you're going to be mixing perhaps copper and fiber or different types of media types because they are insertable in the kind of discrete openings. The next level up when you're talking about category 6 or category 6A or even 5E shielded, if you're talking about that, is the ZMAX outlets. And what those do is those terminate just like they're kind of discrete, similar to a max outlet. The only difference being it's technically a ZMAX panel outlet, and meaning that it doesn't have that the bezel on the front that uses to mount it into a faceplate. It's basically the same body or kernel of an outlet, but it's mounted without that bezel, so it snaps in from the back of the patch panel. You don't see the front of the outlet, you only see the insides of it as shown there. The difference with the ZMAX panels is you do get up to 48 ports in a 1U panel, so the density is effectively doubled if you need it. General recommendation is there's no need to go 48 ports in a 1U patch panel unless you have to. Some people like it. If you're doing a cross connect configuration, you can take a 48 port blade in your switch and mirror it to a 48 port patch panel that's 1U. So it's kind of a like for like in those instances. Just know that the ZMAX panels are for, obviously for copper cabling only, like the HD, so they're not even though they're modular, they don't have the ability to accept multimedia outlets for that consideration. And then finally, the TerraMax panels are designed for category 6A or 7A UTP or sorry, not UTP, but shielded cables. So they would terminate either Terra outlets or ZMAX shielded outlets if you so choose to do that. In that case, the ZMAX or the ZMAX outlets would be the same outlets used in the work area that have the color-coded bezels on the front of them. So if you did want, really nice, elegant color coding that looks the same as the work area in your Terra in your patch panel, you'd use a Terra Max patch panel for those. Lower density, doesn't have 48 ports in 1U. It has 24 ports in 1U, but it is available in both black and silver. So it's one of the only panels we have that's not available in just black. So there are some options for shielded cabling patch panels. Now, when it comes to connecting blocks, again, it's really designed for type of low speed applications. It's probably not going to terminate a lot of horizontal cables as much as it might be used to do some connections within a building between point A and point B, even for some service provider access that they choose to do that on. It's been used in a lot of residences over the years. The most cost-effective solution for connecting blocks is the S66 or the 66 style connecting blocks. All the IDCs are on the front of that blocks. It goes up to Category 5E and can be ordered in pre-wired, meaning that it has the ability to support 25 pair connectors on the side of it. Although it wouldn't be Category 5E at that point; it'd be kind of dummied down to Category 3 for kind of voice grade applications. But the primary termination of that is a 66 style punch down tool, single position punch down tool. And those are not really designed for rack mounting. It's really designed for walls, so definitely more of a legacy type of design or low speed or sometimes small office, home office type applications. But you do get 50 pair capability just in the block shown here in the M150 block. A little bit more commonly used for some higher speeds, and because it has some more modularity in terms of ability to use test adapters and patch plugs, is the S110 connecting block, which is Siemens' version of the 110 connecting block. So it's designed to be wall or rack mountable, still limited to Category 5E, still has some pre-wired options for some lower speeds on there, but does have the ability to support mounting on a rack as well as a wall. So in this case, you're actually as opposed to punching right down in the front. You will punch down in the front, but then you have to insert those colored connecting blocks directly over the top of them to do the termination and carry that forward to where you'll be doing some of your connection points. And those connections can either be through a cross connect wire or can be on an S110 style patch cord. And then the third option is the S210 block, which is a version of the S110 block designed specifically for use for Category 6. The asterisk there kind of identifies the fact that it can be used as a consolidation point for Category 6A UTP systems as well. So just something to keep in mind. Connecting blocks are sometimes a nice alternative inside of a zone enclosure as an option to patch cords and patch panels. No pre-wired options available for that. It's designed to be used, same kind of concept as a 210, just less dense, so you're still punching down and introducing the connecting blocks. Can be mounted on a wall or rack, but does have lower density. So in the footprint for the S110, that's a 100 pair block. For the footprint for the S210, that's a 64 pair block. So there's a little bit of a reduction in overall density. So it's talking about what connects the work area outlets to the end devices or the patch panels to the equipment in the telecommunications room are patch cords. As we said, also kind of known as equipment cords. You hear them used as references, modular cords. So for these types of applications, these cords are typically going to be 4 pair for the higher speeds. There are some instances, like I mentioned with Terra, where you might be able to use 2 pair cords, things of that nature, but nearly all installations you're going to come across are going to be 4 pair patch cords. These are can be solid or stranded, but are typically going to be stranded conductors. Stranded conductors tend to be more flexible. And so when your patch cords are the part of the installation that are constantly moving and being routed, you want to introduce that flexibility. You'd see solid situations perhaps in a cross connect scenario if you want to address that cabling in from the switch to the first patch panel. Solid cables are a little bit easier to manage and form and bundle together. In some cases, you also have solid patch cords that would go from a zone enclosure out to the work area if you weren't doing your own field terminated plugs on there. But for the most part, you're going to see stranded cable conductors. Now, it's important that the cords have to be the same category or higher as the installed cabling. So if you have a category 6A permanent link and you put category 6 patch cords on there, that system is only going to operate to category 6. It's the lowest performing component on there. So Could you go with less expensive cords or a lower category of cords day one and replace them as you go? You absolutely could. You could get 5e cords day one to support gigabit Ethernet, and then if you want to go up to 10 gigabit at a later point, you could get rid of the 5e cords and go with category 6a cords. Not ideal because you're paying for the cords twice, but if that's maybe a customer's decision point, they certainly have that. And the construction of the cords really needs to be the same as the horizontal cable. So if you're installing a UTP system, you should have UTP unshielded patch cords on there, and the same thing if you're installing a shielded system, you should be using shielded patch cords because that's really what they're modeled for. And they can work with each other, but they're not really ideal. And in some cases, they can actually add up and result in performance below the intended category. So you always want to have the same construction of cords as you do in the horizontal cable. And patch cords are not something that's readily constructed in the field consistently. Even with some of the higher grades like Z plugs, certainly have the ability to support that, but that makes for a very expensive patch cord. But certainly would be potentially an option. But as a rule, the cords should be factory terminated, and you have the benefit of having them pre-tested in lots of different colors without having to carry all that inventory on there. So let's move on to the next slide. Siemens offers quite a few different patch cord types, and this probably seems a little bit overwhelming, but it's really not. It really just boils down to the categories of cabling that you're going to be using and maybe what you want to have and use them for. So let's starting with the MC cords. The MC cords are standard cords used for category 5e and 6 UTP only applications. They have a clear boot and a color clip compatible design, meaning that we can actually install an inexpensive snap-on clips on the back of the boot, which is good for, say for example, you wanted to inventory all white cords and use the colored clips for color coding as opposed to inventorying red cords and green cords and blue cords in different lengths. The color coding clip is kind of a nice feature on there, but just for 5e and 6 UTP systems. Now, skinny patch is something that's relatively new in the industry the last couple of years, and these are cords that are constructed of a smaller gauge. Instead of being 24 or 26 gauge or 28 gauge cord, which means they have a smaller OD, which is nice when you're running a lot of cords in a telecommunications room where the vertical cable management sometimes can be challenging. So skinny patch is not only available as a standalone, but in some cases like our Lockheed cords, we'll talk about in a minute, skinny patch is also an option to use with the Lockheed cords. So skinny patch is not really designed for commodity 5e cords, are pretty small themselves. It really reduced the overall diameter of category 6 and 6A patch cords. Available in UTP shielded, though not in a solid option. It's just stranded construction on those, and the color code clip compatible as well. Those are really designed to just, again, reduce those overall cable diameters if that's the case, but they do have some limitations, meaning that instead of having 10 meters of stranded patch cords between the work area and the telecommunications room, you are limited to 8 meters because of that smaller gauge construction on there. The next one is the blade patch cords. The blade patch cords are really designed for high density switch applications, and that you don't have a latch on the top of the boot that you have to defeat to pull the cords out. You simply can snap them into the front of an outlet, and then what you do is you kind of push forward on the cable and pull back on the boot to disengage them out of a lock. So if you have a high density switch where it's very challenging to get into those locations and defeat that latch, the blade patch is ideal. And you can see it's available in 5e, 6, and 6a, shielded in UTP. No solid option because it really wouldn't have any application for that necessarily. It does have a colored boot of its own, but not a color-coded clip on this one. So in this case, the boot is color-coded, not a color-coding clip that's available separately. And then that brings us to the Lockheed patch cords, which has actually been revised recently in kind of third quarter of 2020, released with its second generation of cords, and that's available for category 6 and 6A in both UTP and shielded. And what Lockheed will do is actually designed to plug into an outlet, snap the lock on there, and the plug can't be removed from the outlet without the key. So ideal for kind of areas where the general public might be out there and doesn't want to disconnect, like we kind of showed with that wireless access point at McCarran Airport, or critical circuits that maybe you want to make sure nobody accidentally disconnects, even if it's in the telecommunications room because it's critical data. Maybe it's as a service provider link, or maybe it's for an executive connection point that can't be disrupted. No solid options for those. Again, it's really designed to be used just in the telecommunications room or work areas, and features a clear boot, but not the same boot as our MC and skinny patch cord, so it's not able to use the color-coded clip. The ZMAX are the standard patch cords for category 6 and 6A. So it doesn't have a locket or a blade patch or a skinny feature. It's just category 6 6A basic designs. Available in UTP, shielded with a solid cable option if you did want to use some solid cables for a cross connector in sealing type of application, with a clear boot and the colored clip capability. And then finally you have the Terra patch cords, which are really a way to go from the Terra outlet and convert to an RJ45 type of footprint. And so obviously those are higher performing systems. The 6A would be Terra to modular RJ45. Category 7A would be like a Terra to Terra style patch cord. It's not a UTP system, obviously. It's a fully shielded system solution, so shielded patch cord is only there. No solid options. The boots themselves are colored, and there's no color-coded clips to go along with those. So a little bit of a different type of design. Now, we had talked earlier about the modular plug terminated link, or MPTL, and the Z-Plug is Siemens Solutions for terminating those MPTLs. Z-Plug is really was designed day one for use to terminate to the devices that we've noted, such as wireless access points and security cameras and PoE lighting fixtures, things of that nature, and really, but at a high performance level. So available to support termination of 5E, 6 as well as 6A fully shielded cables, even category 7A SFTP style of cable. Because it was designed from the ground up to fit into these types of locations, we really went out of our way to make sure that it had the shortest footprint and smallest diameter in terms of getting in there. So we did everything from chamfering the edges to having the boot be kind of optional, so we could get into some of those challenging locations that the MPTLs typically call for. The nice part about these plugs is it's not a legacy style plug where you're trying to feed conductors in through kind of tiny slots, which is difficult to make sure you get the color codes right. This actually laces very similar to, and terminates very similar to a ZMAX module, in that you just have to kind of insert a cable, follow a color code, and then trim them and insert it into the Z-Plug termination tool. So it's a fairly easy termination process, and certainly much easier than legacy plugs. And the nice part about it is a single plug part number. It handles both shielded and UTP cable, covering those full ranges, which allows it to be used from category 5E all the way up to category 7A. The latch protector itself can be color coded if you want to designate that a color coding, and it is compliant with UL 2043, which we mentioned allows it to be used in air handling spaces, so in a plenum space where a lot of these IoT devices are located. So another way to deploy cabling from point A to point B, besides just horizontal cabling and terminating onto patch panels and outlets, is actually to deploy copper trunking cables. And this is primarily used in data center types of applications where either there's not the experience level or they're looking for more rapid deployment. But it is an elegant solution that's pre-terminated and tested. Although once installed, it needs to be tested again to make sure nothing was damaged during the installation of itself. But it effectively can be, snapped into patch panels, rolled out, snapped into patch panels at the other end, tested and deployed, which can definitely save in deployment time by as much as 75%. So it's a significant cost savings to do that. Although you don't have the bundles themselves. Sometimes might take up a little bit more space in some of the pathways, and you have to be aware that you have a large ends on each side that are maybe less capable of passing through openings than would be individual cables that are later terminated. But certainly an option depending on the application, available for UTP and shielded in all categories. And just to talk a little bit about, we mentioned indoor-outdoor cables and OSP cables and where things would be, where some of these cables might be used. Here's an instance where you have an application where you might use an OSP type of cable, within a single facility. So in these instances here, you have an OSP cable because you're going into what's referred to as a wet location, which is when you have conduit within the slab of the building where the moisture can build up, and the cable might actually be sitting in a wet type of environment. In those cases, you have to either you have to use an OSP cable in those locations and either transition or enclose and conduit those cables all the way to their termination points where they leave that. So you might come out of there and bring it to a zone box maybe and transition it to an inside plant cable, or you might just extend it into conduit where it comes up all the way back to the MDF or IDF. But that's an application within a building where you might see, or you would see, an OSP cable be used. Now, when we talk about inter-building cables, which is cables between two buildings, that's another example where OSP cable would be used. In this case, it's shown maybe in conduit or underground, but it could be deployed in kind of an aerial environment or direct buried or anything that we've talked about there in the previous slide. In those instances, when that OSP cable enters the buildings, not only does it have to either transition or be installed in conduit, but also has to have some primary protection. Uh, kind of building entrance protectors, if you will, to ensure that anywhere that cable, for example, if there was a voltage surge or lightning on something on the outside, they could transmit volting. It's a primary protector when it enters into the facility. So those are something installed by third parties, and it goes from there. But that's something that's absolutely required when you enter a cable into the building. So a little bit of a different application than within a building, but OSP cables between buildings is extremely common. So the third example that you might see is where you're going from outside the plant to an external device, effectively coming inside the plant. So in these instances, you're going from either maybe a security camera or some kind of pedestal or outdoor device, bringing that OSP cable somehow into the building, whether it be underground or in a conduit outside, something of that nature, and bringing that into the building. And then you need to transition from there into a inside plant cable. So in that situation, you'd want to transition to, maybe you'd use a max patch panel or a Z plug or anything you might want to use there to transition that back into an inside plant cable where you can then route the cable up into your telecommunications room. And I did mention earlier, if you did use indoor outdoor cable and that was a plenum environment, you wouldn't have to make that transition. You could just, kind of come in right into the building and route it directly up to your telecommunications room without the transition. So it's important to know what the environment of that cabling actually is from when it enters the building to where it actually will terminate. So that wraps up Module 2 for our online registered installer training. Next up is going to be Module 3, copper testing and termination.